Welcome back to All This Math. This is Professor Parker, and on this lesson, we're going to be graphing a parabola. Now, first of all, what is a parabola? A parabola is a graph that looks like a U, right? It could be a right side up U, it could be an upside down U, it could actually be a sideways U, right? But when we have y equals, x squared and whatever, then it's going to be either a right side up U or upside down U. When you have x equals y squared, then it's going to be a sideways U, right? But here, this is going to be either a right side up or an upside down U. Now, the way we know if it's going to be facing up or opening down is the a value, which is the coefficient of the x squared term. So if the coefficient of the x squared term is positive, then it's going to be a U that opens upward, right? If this was a negative in front of here, like if this said negative 2x squared or negative x squared or negative 3x squared or negative 1/4 x squared, then it would open down. All right, so that's key information also when you're graphing. So a typical way to graph a parabola is to plot the vertex. Well, basically find 5 points. Find 5 points, right? 5 points. All right. Where you plot you find the vertex, you plot it, draw your axis of symmetry, and then find 2 points either to the right or the left of the vertex, or to the right or left of the axis of symmetry. The axis of symmetry is just a vertical line that is basically the boundary line or the divider line between one half of the parabola and the other half of the parabola. And it's just as many points on the left side of that line or that axis as it is on the right side of that axis. All right. So first step, we're going to figure out what the vertex is. The vertex is a point. It's got an x value and it's got a y value. All right. Now to find the x value, I got this little formula written right here. X equals negative b divided by 2a. Okay, we're going to use this formula. Now, in case you're wondering, what is b and what is a? B is the coefficient of the linear term. 8x is your linear term, meaning it's the term that has x to the first power in it. All right, so b is the coefficient of the linear term. A is the coefficient of the quadratic term, x squared. We already talked about that because A determines whether the parabola is going to open up or whether it's going to open down. If A is positive, it opens up. If A is negative, it opens down. I'm going to say it again. If A is positive, the parabola opens up. If A is negative, the parabola opens down. All right? So let's plug our numbers in and get to the math. All right? So we're going to find x first, and then once we find x, then we're going to take that x value, plug it into the equation, and then figure out what y is that matches up with that x. That's going to be our vertex point. So negative, now, the formula says negative b. So even if b was already a negative number, that means you're going to have a double negative. Don't forget that. All right, you're going to have a double negative. Now, in this case, b is positive. It's a positive 8. So you're going to have negative 8 over 2 times 1. Because a is 1, right? The coefficient of x squared is a 1 because there's no number written there. So this is how we set it up. So now we just got to simplify this. So this is going to be equal to negative 8 divided by 2, which is equal to negative 4. So negative 4 is my x value. That's my x value of my vertex. Now let me talk a little bit about the vertex. I took it for granted that you know what a vertex is. When I said that a parabola either opens up or opens down, the vertex is the lowest point if it opens up. So it's that middle point at the bottom, right? The lowest point if it opens up. And if the parabola opens down, then it's the highest point in the middle of it, right? So the vertex is either going to be your lowest point, or your highest point, depending upon what the parabola looks like. All right, this particular parabola opens up because A is positive, so the vertex is going to be the lowest point out of all the points on the parabola. And the parabola is going to open up and look like a U. All right. So that's my negative 4. Now I got to figure out what y is. So y is equal to negative 4 squared plus 8 times negative 4 plus 21. All right, look what I got. Negative 4 squared plus 8 times negative 4 plus 21. Where did that come from? It came from the original equation, right? Or the original function. X squared plus 8x plus 21. Negative 4 squared plus 8 times negative 4 plus 21. All right, now let's do the math using order of operations. So we're going to have 16 minus 32 plus 21. All right, so 16, negative 4 to the second power is going to be positive 16. 8 times negative 4 is going to be negative 32. So that becomes minus 32, minus 32. And then plus 21 comes down. So 16 take away 32 is going to be negative 16. And then negative 16 plus 21 is going to be positive 5. All right, so that means that our vertex has coordinates of negative 4 and 5. Negative 4 and 5. So we could say V is negative 4 and 5. So we go over here and we actually, well, you know what? Let's pick some points first. So this is going to be my vertex, right? It's going to be my vertex. Now, we want 5 points total, right? If we want 5 points total, the instructions on this particular problem were to use the 5-point method to graph the parabola. So I found one of my points. So it's 1 down, 4 to go. So now, because a parabola is like balanced, it has a line of symmetry or an axis of symmetry. Once I find 2 points on one side, I can find 2 points automatically that are on the other side that are basically just mirror images of those 2 points that I found on one side. So if I find 2 points on the right-hand side, then I can just figure out, okay, well, what point is level with one of these points that's just as far away from the axis of symmetry as this point is, but on the other side, right? That's another 2. That's how you get your other 2 points. So you'll have a total of 5 points. All right. So let's set up a little table and pick some X values and then figure out what the Y values are, just like how we did with finding Y right here. So do X and Y. Now, this is my vertex. My vertex is at, my X value is negative 4. So if I'm counting by ones on the X axis, I'm going negative 1, negative 2, negative 3, negative 1, 2, 3, 4. Yeah, this will be negative 4. So let's say I pick 2 points to the right, or I pick 1 point to the right. So 1 point to the right might be, I don't know, I'll do negative 3. Let's do negative 3. All right, that's one of them. And then to the right of that, let's do 0. Because 0 makes the math easy. All right, and 0 actually means that I'm dealing with my y-intercept. All right, so now, in order to find my y value when x is negative 3, I go back to the original equation. I substitute negative 3 wherever I see an x at. So I got negative 3 squared plus 8 times negative 3 plus 21. And I just use order of operations and I simplify. Negative 3 squared is 9. And then this is going to be negative 24. So I'm talking about 9 minus 24. 9 minus 24 is negative 15. Negative 15, because 24 take away 9 would be 15, but it's 9 minus 24, so that's going to be negative 15. And then negative 15 plus 21 is going to be positive 6. All right, so now I got 0. I plug 0 in, 0 squared. It's going to be 0 squared plus 8 times 0 plus 21. That's 0, that's 0, and then 0 plus 21 is just 21. So these are my 2 points. So I got negative 3 and 6. I got 0 and 21. All right. So let's start plotting some points. Let's plot the vertex first. So let's start at 0, 0, 0, the origin, right? And plot the vertex. So let's go to the left 4 spaces, 1, 2, 3, 4. And then let's go up 5 spaces. So 1, 2, 3, 4, 5. Right? So I'm over 1, 2, 3, 4. And I'm up to 5, and where they meet up is like right there. That's my vertex. That's my lowest point. All right? That's my vertex on my lowest point. Now, what you might want to do also is draw what we call your axis of symmetry. Your axis of symmetry is a vertical line that basically intersects the parabola, and it splits the parabola into 2 equal halves. All right? So the axis of symmetry is going to be x equals negative 4. So whatever the x value of the vertex is, the axis of symmetry is going to be a vertical line that goes through the x value of the vertex. Always. The axis of symmetry is a vertical line that goes through the x value of the vertex. So if the x value of the vertex is negative 4, then your axis of symmetry is going to be x equals negative 4, which is going to be a vertical line. All right, so let's draw that vertical line. And I like to use a dashed line when I draw that line. So I go boom, 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 boom. So this is my axis of symmetry. This line right here cuts the parabola in half. So the parabola is going to do something like this and then something like this. All right. So let's plot this point. Where's -3 and 6? So I go to the origin. I go over to -3, -1, -2, -3, right? And then I go up to 6. I go up 6. I go 1, 2, 3, 4, 5, 6. And then where do they meet up at? They meet up like right here. All right, meet up like right there. All right, so that's my second point. All right, now this point right here, 0 and 21. Now this one's a little weird. This one gets a little weird, right? Because 0 is right here, but if I go up 21 spaces, if I'm counting by ones, I don't have 21 spaces on this graph. 21 would be all the way up here somewhere, right? Off the chart, like off my graph, off this dry erase board and everything, right? So we kind of have an idea of what the parabola is going to do. It's going to go up and it's going to be skinny, right? So let's do this. Think to yourself, what point on the left side of the parabola matches up with this point, the -3, 6 point? This point is one space away from the axis of symmetry, but it's on the right-hand side. So this point has a matching point on the other side of the axis of symmetry, which is also one space away. So look, this point is one space away from this to the right. There's also a point that's at the same height. It has a y value of +6, but except the x value is not -3. The x value is going to be -5 because it's one space away. So it's going to be right here. Right? So basically, we have an idea of what's going to happen in this graph, right? Our other point was going to be 0, 21, which is off this graph. So it kind of lets us know what the graph is going to do. It's going to go up and get kind of skinny. So I can just, based on this graph, I can just, draw that, right? And remember, it's not a point. You don't draw it. It doesn't look like a V. A parabola does not look like a V. Absolute value functions look like a V, right? But this doesn't look like a V. It should be like a curve. It should be a smooth curve, as smooth as you can make it. So this should go like this. And it's going to go up like that. It's going to do the same thing over here. Now, that's not perfect, but that's an idea of what it should look like. All right, so that's what your graph should look like. Now, we didn't plot 5 points. But the only reason we only plotted 3. We plotted the vertex, and we plotted one of the points that I found right here, -3 and 6, and I found its corresponding or matching point on the other side of the axis of symmetry, right? So we got 3 points. Only reason we didn't plot the other 2 was because one of them would have been off the chart. I wouldn't have been able to graph it. I would have been writing on my wall all the way up here somewhere, up in my ceiling, right? And then there would have been a matching point to that one on the other side of the axis of symmetry, also on my ceiling somewhere. So I didn't need to draw that. But we don't have to draw those points because the purpose of the points is so we have an idea of what the parabola looks like. We can get a good enough idea of what the parabola looks like from just these 3 points right here, from the vertex and these 2 points, right? And also knowing where the other points are. All right, it gives us an idea of what's going on with these points. So this is basically how you graph a parabola. You find the vertex by using this formula right here, -b/2a. You find the x value of the vertex. Then once you find the x value of the vertex, then you take that number, plug it into the original equation to find the y value of the vertex. Then you have the vertex, because the vertex is a point. It's either the lowest point if the parabola opens up, or it's the highest point if the parabola opens down. All right? So then you plot that. That's what we have right here. And then you want to find, using this 5-point method, you want to set up a little chart, right? Pick some x values that are to the right of the axis of symmetry. And let me emphasize that, because I think it's important to draw the axis of symmetry, because that can be helpful in terms of visualizing what you're dealing with, right? The axis of symmetry cuts the parabola into 2 equal halves, a left side and a right side, right? So you just pick a x value, a random x value that's to the right of the vertex, and the vertex is at -4, the x value of the vertex, right? So we're not worried about, when we picking points to the right or to the left, we're not worried about the y value. We don't worry about the y value because the y value is like the height. That deals with the height. The x value deals with the left and right, the horizontal, right? X value, horizontal, Y value is the height and all that. All right. So you just pick a couple points to the right. Like I picked -3 and 0. I picked 0 thinking that was going to make things easier because it was going to give me the y-intercept. But it didn't because it gave me 21. And also, that's another thing too. Automatically, if ever you're trying to graph a parabola and your quadratic is in standard form, this is standard form, right? Not vertex form, but standard form. The C value, this is C. A is the coefficient of the quadratic, x squared. B is the coefficient of the x term or the linear term, which is 8. And C is the constant at the end all by itself. That's what C is. So automatically, your y-intercept is going to be this number at the end. If the equation or if the function is in standard form. If it's in vertex form, then you're dealing with something else. But in vertex form, that's cool because when it's in vertex form, you can look right at it and immediately tell what the vertex is. So that means you don't got to use this formula. You don't got to use negative b over 2a and then plug the numbers back in. You don't got to do all that. All right. So I've shown you how to do it. I've shown you how to graph a parabola using the 5-point method. Now your job is to go get some practice. All right. So do that. Go get some practice. Use this video as a guide, and I'll catch up with you on the next video. Peace.